welcome guys today once again this afternoon and thanks for joining on a holiday. So I am again Shailendra Kadre, your host as today as usual. So before this we took two classes on normal distribution and we finished it in detail and we saw how to solve useful problems with the help of normal distribution. See, I want to like tell you now. Now you might have understood the example, like the importance of distribution. Okay. So what are these tables we saw? Z tables, right? This Z table, negative Z table. So all these Z tables are based on this particular equation. Understand? This particular equation. They are all derived from this equation. Okay. So they are basically specific to normal distribution. Tables are distribution. So we know this formula. That's why we are able to derive those tables. And if we know those tables, simply by calculating z values, we are simply by calculating this z value, we are able to solve like some real life type of problems, right? So these problems which we solved yesterday are very near to what real life engineering expects. Okay. So now you might have understood the importance of modeling a phenomena with the help of a distribution. So distribution is nothing but this kind of formula. Okay, this kind of formula. So this y is equal to fx is equal to this formula, right hand side big formula is specific to normal distribution. So bell curve. So this defines your bell curve, provided you know sigma and mu. Okay, so similarly different they are making many different distributions are there. So maybe 15 or 20 more distributions are the useful distributions are there in statistics, but all of them may not be that important in data science. So we'll be studying only ones which are more useful and I'll say more commonly used. So now you got the importance of modeling with from that formula we got these tables, and from these tables we are able to solve some real life problems. So like if we are doing any experiment like a simple experiment like I'm taking 100 eggs out of the market and trying to find their a weight. So I'm trying to find their weight. So to like that is also an experiment, like I'm trying to find a weight, so I would like to model it with the help of some distribution, the nearest distribution. But if any natural phenomena or any social science phenomena, if you are not aware what is the distribution, generally people take it as a normal distributed. Okay, so if you are not aware what is the distribution and phenomena is either social phenomena or a natural phenomena, you model it with the help of this natural distribution. Natural distribution, if you model, that means you have this particular formula at your disposal. For every x, you can calculate y. Y is nothing but your probability. Y is nothing but your probability. X is nothing but your input x. Like that may be experiment number or some value of x for which you are getting calculating y. Y is nothing but your probability, right? So you have this formula and you can draw this distribution. When you have distribution, we have this 65, 95, 90, 99.7 property. And there are several other properties of natural distribution which we studied. Okay. So most important was calculation of Z score. And with the help of Z score, we studied based on this formula how to calculate cumulative probability and all that. A lot of problems we solved yesterday. So now you got the importance of modeling a natural phenomena experiment, a natural phenomena or a social phenomena with the help of a distribution. Distribution means you have a formula to calculate probability all the time. Now, suppose you have more than 30 samples with you. Like if you are throwing the experiment of throwing a coin. So suppose you have thrown coin more than 30 times, 30 or more times, 30 times or more, and noted whether it is coming head or tail, then you can safely go for normal distribution because it demands that sample size should be more than 30. But what if your experiment is very costly? I'll give you one example. One guy was working in a chemical company. It's a real life example. So one guy was a data scientist and he was working for he was PhD from IIT Bombay in data science, and he was working for a petrochemical company. So they were doing some scientific experiment. What scientific experiment? Some bacteria, some bacteria in the lab conditions. So there are different 150 different parameters to control in the experiment, like temperature, pressure, concentration of the solution. There are like three only I told. There are 150 such parameters. Under certain combination of those parameters, that bacteria used to produce petroleum. Some kind of chemical which I don't remember. Some cheap chemical used to convert into petroleum. So it's a natural thing. We are interested in petroleum, right? Everybody is interested in petroleum. So if some cheap oil or some cheap grease or something like vegetation we can convert into petroleum, you are welcome. Many people are trying, like food waste, or not food waste, but vegetable waste or green waste. If you have, many people are trying to convert it into petroleum with the help of some bacteria and enzymes. So for one such experiment they were doing in a lab, and there were 150 parameters to control. For under that condition only it will change, it will produce petroleum. It is very difficult. Like suppose say temperature equal to 20 degree, pressure equal to 2 atmosphere, concentration equal to 30%, something like that. So three only I told you. There are 150 such parameters to control to produce petroleum. Under that, he used to produce very small quantity of petroleum. So they are trying to commercialize it. So like controlling 150 parameters in the lab and getting the quantity of petroleum, small quantity of petroleum, naturally you can imagine it's not a cheap experiment. It's a very costly experiment and very difficult to control 150 parameter at time. And so it was very time consuming. So what was their aim? Under the given those values of those 150 parameter, different values of those 150 parameters, how much is the quantity of petroleum produced? They wanted to predict. What they wanted? They wanted to produce how much petroleum is getting produced under different values of these 150 parameters. So they wanted to find the best values of best combination of those 150 parameters under which that more the petroleum production will be more. Okay. So they wanted data scientists, like they did some 9 or 10 experiments only, right? They told their budget was only that much to do only 9 or 10 experiments. The director told, I cannot fund you more than 10 experiments. So said it only 10 experiments. So they varied 150 parameters and find out how much petroleum was getting produced under the different combinations of 10 different combinations of 150 parameters. Only 10 experiments. But after that, they wanted a data scientist to take data from those 10 experiments. And if they vary the parameter now what was the unknown? Unknown quantity was the petroleum produced. They couldn't do it in the lab. So they wanted data scientists to predict it. What they wanted to predict? What the data scientist should predict? The data scientist should predict the quantity of petroleum produced under different combination of different values of 150 parameters. They will vary the parameter, give the different values, and mathematically you have to find out, like with linear regression or with random forest or with deep learning, whatever you want to find out. They will give you different values of parameters, 150 parameters, and based on that you should be able to tell by computer simulation. By you making a computer program, you should be able to tell how much will be the predict, how much will be the quantity of petroleum produced. So in that, naturally they couldn't afford 30 experiments or like that, because the experiment was very costly. So they gave data for only 10 experiments. They gave data to the scientists, and based on they told the data scientist, that he was my friend only. So they told the data scientist that you now, for next experiment onwards, you have to predict the quantity of petroleum produced, based on different values of parameters. Will give 150 parameter, different values will give, and the quantity of petroleum produced, you have to predict. So it's a regression problem. So if you study a little bit more data science, you will come to know that there are two main type of data science problem. One is regression and one is classification. Regression means to predict some quantity, continuous number. Classification means suppose some there are two results of experiment. Like we are throwing a coin. So you throw in the coin in the air and you have to predict whether it will be head or tail. Such is called such classification is called classification problem because we are classifying whether it is head or tail, yes or no. So that is classification problem. Prediction means you are calculating some predicting some quantity like quantity of petroleum. So it will be in milligrams or grams or whatever that you are predicting, right? So these two type of main problems are there in data science. So now I am giving you example under which they were given data for only 10 experiments. So in such experiments, where quantity of experiment, the quantity of number of experiments are less than 30, you cannot go for normal distribution. So you have to come up for it another distribution, which is called student t distribution. And if I'm not wrong, this student was a name of a scientist. If I'm not very sure, but I think it was the name of some prominent scientist who invented this distribution. Okay. So number one things to remember about student t distribution is it is very similar to normal distribution, but normal distribution is used if that and the sample size is more than 30. If you have sample size 20, 10, less than 30, 25, 27, 12, 5, anything less than 30, you have to use student t distribution. So first of all, it is a special case of normal distribution. That is one property. Another property is also like we know that normal distribution also is for a continuous number. So it's a continuous distribution. So this also is a continuous. Student t distribution also is a continuous distribution. It is not a discrete distribution. It is a continuous distribution. Okay, like normal distribution, the mean and mode and mean mode and median are equal and they are located at the peak. Normal distribution also we know that mean equal to mode equal to median and is located in the middle peak. So that's the same thing is applicable to student tree distribution also. Okay. Now another case when we use student tree distribution is when population, standard deviation we don't know. One case is number of samples less than 30. That's where we'll use student tree distribution. And another case is if population standard deviation. Huh? If population standard deviation is not known, in such a case also we go for student tree distribution. So now you will like tell me like, sir, you have told three properties, but you have not told us how does it look like. So next is that only. So see, the blue curve here, there are three curves I have shown. Three curves I have shown. The first you see the top one, like the highest, which is steep peak, blue one, blue curve. So this is your standard normal distribution, which is your normal distribution, standard normal distribution. Sample size more than 30. Now you see the middle one, middle curve, the red curve, the second peak, second peak. So that is the t distribution when n is close to 30. N is close to 30. N means sample size. Sample size is close to 30. That is the red curve. And if n is much smaller than 30, then it is green curve. Understood? So now you got the feel of t distribution. How does it look like? And when it is much less, n is much less than 30, n equal to 30. And standard normal means n is much greater than 30. N may be 40, 50. Then it will become. So in t distribution, suppose there is given a t distribution. When we increase sample size 30 or beyond, it becomes a normal distribution. Understood? When in any student t distribution, sample size is 30 or beyond, it becomes a normal distribution. Is this understood?
Yes, sir.
Yes, sir.
Everybody, Jignesh,
Yes,
Samir,
sir.
Sarthak.
Yes, sir.
So now you got the feel of shape of t distribution. You see the green curve. It's a very shallow curve. It's a very shallow curve. So it is for n less than 30. When n is approaching 30, you will see that normal distribution and t distribution look almost same. And n is much greater than 30. If n is greater than 30, 40, 50, 60, like that, number of samples, the t distribution becomes normal distribution. Got it? Everybody got it? So there are two cases when we'll use t distribution. Number one, sample size is less than 30. Number two, population standard deviation is not known. See, whatever problems we solved so far, many problems we solved with normal distribution. Their population standard deviation was given. Population, mind it, population standard deviation was given to you. That means it was known. But if population standard deviation is somehow not known to you, then you will go for student t distribution. That is one case. Another case, if number of experiments or number of samples are less than 30, then also you will go for student t distribution. Otherwise, you can say that a student t distribution is a of special case of normal distribution. What is special case? If n is less than 30, if n is less than 30, then normal distribution becomes t distribution. Got it? So now next thing is this we already studied. So with two cases again, sample size is less than 30, we go for to t distribution. And if population variance is unknown, then also we go for t distribution. Okay. So as you can see, around mu, like mu is equal to zero in t distribution. So around mu, this t distribution also is perfectly symmetrical. Left hand side, whatever shape, you put a mirror image, it will right hand side also shape. So mean, mode, and median are equal, and they are located at the center. You got this? And same thing is applicable for normal distribution also. Mean equal to mode equal to median, and that is also located at the center, peak, right? Have you got this?
Yes, sir.
Okay. So now there are like some examples in which we use this t distribution. So like apart from being used in construction of confidence intervals, like confidence intervals we have not studied so far. When we'll come to hypothesis, there is a lecture on hypothesis testing. In that we'll study what is confidence interval. So for in that we use t distribution. Apart from that, just remember these four cases where so I'm not explaining you much. Just remember these four cases where generally t distribution is used. Single population mean, the difference between two population means there are two different populations, and we want to find out their difference in their means. So in such a case also we are applying t distribution. The mean difference between paired population, like if two populations are dependent somehow, like two populations are dependent means, first I'll take that this person is a Indian. So given that this person is a Indian, what is the probability of this person belonging to Karnataka? So first he is Indian, and then what is the probability of him belonging to Karnataka? So this kind of population, if I take, then their mean difference, their average, if you take average of such populations which are dependent on each other. So if you want to find their difference, then also we apply t distribution and the population correlation coefficient. So this correlation coefficient also we have not studied so far. So in one of the future lecture, we'll study it. It will be towards the end. So these four, I'm giving you example. Don't break your head too much on this. We are not going into detail. Just remember that these are the cases where generally student t distribution is used. So I'll stop at it, and I'm not going into much detail right now. Okay. So just you like for us, it is sake of knowledge, you remember. Okay. Now my question to you is, what are the main parameters of normal distribution? Can anybody tell me? So many times we have studied it. What are the main parameters of standard normal distribution? Tell me. There are two main parameters of standard distribution. You should be able to tell now.
Yeah, mu is 0 and standard
No,
deviation
mu is
is what?
0. That is for standard normal. I'm
Yes.
asking in general standard parameters, in
Okay.
general, which is a normal distribution. What are the two main parameters? Any given normal distribution. It can be standard normal or it cannot be standard normal. Anything. There are two main parameters. You should be able to tell now. Sarthak, can you tell?
No, sir.
There are two main parameters of standard. The two parameters of C. I'll take you to the formula again. Formula is this. Seeing this formula, can you tell me the two main parameters of this formula? Can you tell based on this formula? What are the two main unknowns in this formula? We have discussed so many times, no, Anna?
So mean and standard deviation.
So these are the, yeah, that's what the question I'm asking. There are two parameters means unknown. So what are the two main parameters here? Mean and standard deviation, right? So our normal distribution is having two main parameters. X is your variable. Okay. But apart from that, there are two main parameters, mu and sigma, right? Is this understood? There are two main parameters of your normal distribution, which is mu and sigma. Got it?
Yes, sir.
Sigma is your standard deviation, mu is your mean. Amit and Jignesh, have you got it?
Yes, sir.
Yes, sir.
Now, how many, if I ask you like how many, like normal distribution, you have two parameters. What are the now? How many numbers of parameters are there in a T distribution? So I have not taught you. So that's what we are going. See, normal distribution we have two, mu and sigma. So how many are such there in? How many such parameters are there in T distribution? So in T distribution, there is only single parameter. Formula is very simple. It's only one parameter. It is called degree of freedom. What it is called? Degree of freedom. So degree of freedom was something which we learnt in, if you have studied 9th class or 10th class physics properly, or maybe 11th class physics, that each were degree of freedom formula. Like, I'll give you a simple example. It is very simplified example I will give. There is a straight road. There is a straight road and a person is walking on that straight road. Road is straight. There is no deviation. So how many direction he can go? If he has to go along the road only, how many direction he can go?
One direction, two
So
direction.
two.
No, how come two? No, I'm not talking reverse. Only forward he has to go.
Only one.
So one.
Only one. Right? Right now we are talking only about forward he has to go. Backward is no option. So only forward. Only one. So that's called one degree of freedom. Now he walks on the road and get a road where there is a right turn also. There is a straight road and there is a right turn. How many directions he can go?
So two.
So that is 2 degree of freedom. Now he goes further down, and then there is a square where he can. There are 4 roads are meeting. Which how many direction he can go?
So three.
4 direction. No, he can go straight, right, left. Yeah. So you can say 3 direction. So we like so okay. So like how many mm, if anything is moving, how much direction it can move? So generally that is called degrees of freedom. Okay, that is a very crude concept I am giving, and it is from physics point of view for you to understand. Something similar is there, degree of freedom in maths also, which I'm not taking you into much detail. But for this, assume that degrees of freedom in math, I just give some feel of physics. Okay. So in maths, it may be something different, but we are not going in detail. But suppose there is only one parameter in T distribution, which is degrees of freedom, which is given by n minus 1. What is n here?
The sample size.
Sample size, right? So degrees of freedom, which is called df, degrees of freedom df, df is given by n minus 1. Got it? Degrees of freedom is given by n minus 1. So that's what is the only parameter in formula. So suppose I have 10 observations. 10 observation. What will be my degree of freedom?
N minus 10.
No. I have
Sir,
10
9.
observations. How much will be my degree of freedom?
9.
9, right? If I have 7 observations, then how many degrees of freedom I will have?
6.
Now you got it. So that's only this parameter. T distribution formula depends only on this parameter, which is degrees of freedom. And so like I will tell you the formula first. Like this is the formula. Okay. So T distribution formula. No, I will tell you this T table. Yeah. So see, and like that we studied Z table in like we studied Z table in normal distribution. Here we'll study T table. T table means any problem you have to find out the degrees of freedom. Degrees of freedom. So degrees of freedom are given in the first column. Suppose you calculated your degrees of freedom as 29. So and significance level is 0.05. So we have not covered significance level so far, but suppose you know that significance level, we'll cover it in hypothesis testing class. Suppose significance level is something, and I got it 0.05, and my degrees of freedom are 29. Okay, so what will be the we calculate t statistic here? T statistic. So what will be the value of my t statistic here? Seeing from table, my degrees of freedom are 29, and significance level is 0.05. What is the value of my t statistic here?
Sir, 2.045.
2.045, right? So you know how to read this. Now there are two unknown things here, which I have not explained to you. What is t statistic and what is confidence interval? So keep this question for now in your mind. In one of the future classes, I'll answer them. Okay. So in this distribution, there are two values, two things are important. Confidence interval, what is confidence level? Generally, it is point. We keep it as 0.05, and t statistic for solving the problems. We find out t statistic. So t statistic, and what does it depend? It depends on only one thing: degrees of freedom. So you know degrees of freedom. Confidence interval is generally fixed at 0.05. So significance level is generally fixed at 0.05. So you just find corresponding to 0.05 and 29. You just read the values. That is your t statistic. So rest your question, you keep it for a future class when we will do like our what is called hypothesis testing. There is a lecture. In that lecture, all these questions will be answered. Okay, so for now, let us park it. So, like a couple of properties of this t statistic, I wanted to give that, like our z statistic. What was the limit of z? What was the limit of z? How much was the lowest and how much was the highest for z? Z score we calculated, na? So
Sir,
how much was the lowest value for z score?
Minus infinity and plus
Yes.
infinity.
And how much was the highest value for the z score?
Plus infinity.
Yeah. So similarly, your t statistics also varies from minus infinity to plus infinity. T distribution is symmetric like a normal distribution. That's what we have studied. Okay. Then t distribution and t statistic depend only on degrees of freedom, which is n minus 1. N is nothing but sample size. Okay. And t distribution is less peaked than normal distribution. Means t distribution curve is shallow compared to normal distribution. As I showed you here, you can see that that blue one is your normal distribution, and that this green one is your t distribution curve. So it is less peak, means it is shallow curve. Peak is less for z distribution. These are the properties, and variance, you know now that standard deviation and variance we have done in one of our classes. I explained you how to calculate it. So in this t statistic, if you want variance, it is given by v upon b minus 2. What is v here? V is nothing but your degrees of freedom. Okay. So degrees of freedom, df divided by df minus 2. That's what gives you your variance. And there is something called skewness. skewness also I'm not explaining you because there is a complete class of skewness. And so skewness is equal to 0 for degrees of freedom more than 3. Degrees of freedom more than 3 means sample size is more than 4. Degrees of freedom is just one less than sample size, right? So skewness is 0 for sample size more than 4. This is what one of the properties. Variance is given by df divided by df minus 2. Degrees of freedom v divided by degrees of freedom minus 2. So these you think you remember right now. So I have not explained you what is skewness. I have not explained you what is t statistic. I have not explained you what is significance level. Okay. So these things will be clear in one of the future classes. I don't want to waste time right now. So once we do those lecture, I will suggest you to revisit this particular PPT so that you can understand the meaning of whatever not explained so far. Okay. So now T distribution formula, the T statistic is calculated by X bar. X bar means mean of that particular thing. X bar minus mu, X bar means sample mean, mu is the population mean. So X bar is your mu, X bar is your uh, X bar is your sample mean, mu is your population mean, and then S is your is the standard deviation for the sample, and root n is the size of the sample. Generally, we will not be dealing with formula. Generally, we will be dealing with these tables only. Okay. But the origin, if you want interested in formula, this is the formula. T is equal to X bar. X bar means sample means minus mu. Mu means your population mean divided by S. S means standard deviation. S over root n. Root n means n means your sample population. So just for your academic knowledge, you have to see this formula. I am not expecting you to remember this. But if you are interested how T distribution, T statistic is calculated, so this is the formula. Okay. But generally, like we'll be going with, we'll just calculate degrees of freedom and then we'll use T table to calculate T statistic. That's how we'll go. Now I have not told you one more thing. How, if you know, see, suppose you know Z score. Suppose you know Z score. You know everything what to do with it. If you know Z score, you can find the cumulative probability, and there are many things you can do with it. But if you have T statistic, what you do with it? That also I have not explained you. Suppose you calculate T statistic, what to do with it? What is its significance? That's what I have not told you. So many things I have not told you so far. So that will be clear in, that will make it clear in like lecture with hypothesis testing. Again and again I am repeating. So right now you remember only couple of things. Number one, T distribution is a special case of normal distribution in which sample size is less than 30 or population standard deviation is not known. T deviation, T statistic curve is similar to normal deviation curve, which is that is also symmetric, but the less shallow. Like T distribution is shallow compared to the normal distribution curve. That is another thing. And third thing you have to remember is mean equal to mode equal to median in the case of T distribution. Only three things if you remember. For now, it is enough. Okay. And you should be like given the degrees of freedom and the level of significance. So level of significance can be 0.2, 0.15, 0.1. But generally, as I said, in most practical cases, significance level is fixed at 0.05. So generally, you go for only 0.05. So given, if I give you degrees of freedom, you should be able to read these statistics from the T table. Okay, so how it is read? So degrees of freedom is 29 here. You see these lines 29 and significance level is 0.5. So my T statistic value is 2.045. So these things, if you, three, four things are, if you remember about T distribution, for now, it is enough for you. Rest all questions will be answered in your hypothesis testing lecture. Okay. So understood, na? So is this any problem? We'll use T statistic in two cases when number of sample size is less than 30 And when population standard deviation is not known, then we'll go for a t distribution. And in most cases, to solve the problems of student t distribution, means whenever your sample size is less than 30, we'll use this t table. Okay, then what is significance level? What to do with t statistic? And all these things will be made clear in the next lecture. Okay, so I have given you. We'll attempt more t-test numerical examples in hypothesis testing part in statistics. Okay, so we'll leave it halfway and then we proceed for the next distribution. So now value of t statistics also varies from minus infinity to plus infinity. Then standard normal distribution peak is sharp and t distribution peak is little shallow curve. And then there are two main parameters in normal distribution, mu, mean, and standard deviation. In normal distribution, there are two parameters, mean and standard deviation. But in t distribution, there is only one parameter, which is called degrees of freedom, which is equal to n minus 1, where n is sample size. Is this understood? Anybody problem till now here? Some things I have not answered, which I am telling you in the future lecture, it will be answered. So whatever I taught, is it understood so far about t distribution?
Yes, sir.
Yes, sir.
Okay. So for now, it is enough. Park your questions, and you should have questions. So park your questions, and we'll see in the later class. Okay. And then we have to revisit this PPT to to increase our level of understanding for T distribution. So next now we go for one more see, like based on normal distribution, you have Z test. And based on T distribution, you have T test. So there is a difference given. So based on what is Z test, what is T test, Z test you already know now. So Z test and T test we'll cover in great detail in our last lecture. Okay, so I'm right now skipping this PPT. So what is Z test? So Z test is dependent on normal distribution. T test is dependent on T distribution. So what are the tests? How to use them? What are the practical problems for that? So we'll discuss in our last lecture. Okay. So right now let us take up one more simple distribution. So that's after this we'll end the class. After this we'll have a couple of numerical example and end the class. Okay. So that is called uniform distribution. Now tell me one thing. I'm throwing a coin. I'm throwing a coin in the air. I'm starting from experiment number 1. So experiment number 1, probability of success means head is 0.5, tail is 0.5. Okay. So only two probabilities, right? Head can come 0.5 probability, tail can come 0.5 probability. Experiment 2 also same probability. Experiment 2 also head equal to 0.5, tail equal to 0.5. Experiment number 3 also same. Okay, result can be different. It can be either head or tail, but probability is same. So whatever my value of x is, means my number of experiment I keep on increasing, the probability doesn't change. So probability means I say probability of success. Probability of success means probability of getting tail. Head. Probability of head, I call it probability of success. So my probability of getting success doesn't change with if I increase x. Here x is the number of experiment. So such a distribution is called uniform distribution. Okay. So now you try to understand this left-hand side plot. So like I'm doing the experiment, you imagine same experiment I'm doing of throwing a coin, and I'm concentrating on probability of success. So probability of success is nothing but probability of getting a head. Okay. So now my value of A, I reach to a point, I do some experiments, and suppose A is my 10th experiment. A is my 10th experiment. See, you can see here A, right? On the bottom x-axis, that is A is written. Suppose A is my 10th experiment. From 10th experiment, I continue my experiments and go till 20th experiment, which is the value of my B. So probability of success will change here. Will it change? Probability of
No.
getting will it change?
No.
It will not change, right? So that's how this plot is. So my between the lower limit A and upper limit B, my probability of success is same, a straight line, horizontal straight line. So that's what you can understand, right? Okay. So this is how this particular your uniform distribution is. So in that the probability function, what between experiment and experiment B, the probability is given by B minus 1 upon B minus A, the cumulative probability. Cumulative probability means area under the curve. Area under the, it's a rectangle, right? So cumulative probability like as we discussed here, I'll show you again. Cumulative probability as we had discussed here. So here we are finding probability less than Z equal to 0.7. So Z, x-axis you read. Z is around 0.7, 0.8. And we are finding probability Z less than equal to 0.8. So that is cumulative probability. We know that, right? So here, similarly in this normal distribution formula also, the like in uniform distribution also, if I have any point between A and B, what will be the cumulative probability? It will be area under that curve, right? Similar. So it's also a curve, right? It's a straight line, but it's also forming a rectangular curve, right? It's forming a rectangular curve. So if I tell you, listen carefully. If I tell you, what is the probability of x? What is the probability my x is between like more than A, but less than B. More than A plus less than B. So will it not be area under that curve? My probability, my x is more than A but less than B. Means in between A and B. So that will be area of that curve. Okay. So my probability of area under the curve. So its probability function is very simple. 1 upon B minus A. There is no variable in this. A is lower limit, B is upper limit. So probability function, probability equal to y equal to fx is given by 1 upon B minus A. That's how my probability is defined. Okay. So now as I go from A to B, my cumulative probability will go on increasing or not. If I go on from A to B, the area of the curve which I am covering will go on increasing. Can you imagine that? If I go from A to B,
Yeah.
I'm covering more and more area of this rectangular curve, right?
Yes.
Yes.
So my cumulative probability function looks like this. Linearly it is increasing, right? So up to A it is 0 because we are not considering it. So A it is 0 and for B it is 1 because the total area under the probability curve is always 1. We know that, right? The total area is always 1. So it will increase from, as I increase from A to B, my cumulative probability will increase from 0 to 1. So I can see it's a straight line here. So this is my cumulative probability function, cumulative distribution function, CDF. A it is 0, B it is 1, and in between it will be constantly increasing. So did you understand that? Like Sarthak, Jignesh, Amit, have
Yes,
you
sir.
understood this function?
Yes, sir.
Yeah.
Okay, so total area under the curve that rectangle is always 1. So at A it is 0 and at B it is equal to 1 and linearly it is increasing. So your CDF, which is your probability function, cumulative distribution function, it is always represented by capital F. And probability function is always represented by small f. And cumulative distribution function is represented by big F. So like you imagine how the area is, it is increasing. Okay. This is how it is. So if you want to define it formally, so this is how it is defined. Small fx is nothing but the probability. Probability is always equally same, right? Is it always same? So what is the value? 1 upon b minus a. 1 upon, what is the value of that bar height? 1 upon b minus a. For a less than x is between a and b. So a is less than equal to x and x is less than equal to, as you can read from here. So when x is less than x is between a and b, the probability is given by constant 1 upon b minus a. Okay. And for x less than a, it is 0. For x greater than b, it is 0. That's how it is. This function is defined. Okay. So how many parameters are there in like probability, like PDF of uniform distribution? I said PDF of normal distribution is 2. For T distribution, it is 1. Now here are how many parameters in CDF of uniform function? How many parameters are there?
Sir, 2.
No. A and B are lower limit. A is lower limit, B is upper limit.
0.
0, yes. Why 0? Because your probability is constant, no? Between
Yes,
A
sir.
and
Yes,
B,
sir.
your
Got it.
probability is constant, right? So there is no parameter, no variable.
Yes, sir.
Probability is constant, right? It is given by 1 upon B minus A. So B is also lower limit, that is also constant. B is upper limit, that is constant. A is lower limit, that is also constant. So 1 upon B minus A is a constant value. There is no parameter, right?
Yes, sir.
Got it now? You have to go on mute, yeah. Amit Parik, you have to go on mute, please. So when x is less than a, probability is 0. And when x is greater than b, probability is 0. In between a and b, it is given by 1 upon b minus a. Now is it understood? Now tell me from your like 9th, 12th class knowledge, what is integration of a constant c? If I say integration, if I write integral sign c dx, c is a constant. Integration sign, I am putting an integration sign, then c is a constant, and dx. What will be the value of that integral? If you don't remember, don't worry. You buy this scientific calculator from Casio, it will directly calculate for you. That's what I am doing. Even if you have forgotten this integration calculation, so don't worry. This calculator does it automatically. So this my model is, if you want to note down, fx 991ex, fx 991ex. It's a fantastic Casio calculator, and we need not change the battery because it is solar. So it's dual powered, solar and dual. So when it is in dark, it will run by battery, and when it is in tube light or say any bulb or sunlight, it will run by solar. So this calculator I have purchased. So I'll give you the, like, for this question I asked. So integration of c dx is nothing but cx. Integration of is c will be taken out. So integral dx will be equal to x. Integral x will be equal to x. Okay. So just for your, if you want to revise your integral, you can look at your 12th class book. Otherwise, not necessary. You can buy. I just purchased it for 1,400, and I am happy. All my integral work it does. Okay. So now you have to remember small things about uniform distribution. Support x belongs to a e. This e, no, so see first row. So it is written x e in the bracket a comma b. E means it's a mathematical symbol, belongs to. So x will always lie between a and b. Is it true or not? For less
Yes.
than a, probability is 0. More than b, probability is 0. So we are considering only x between a and b, right?
Yes.
So this is read as x belongs to a between a and b. That's how you have to read it. X belongs to a, belongs in between a and b. So lower limit is a, upper limit is b. That is first thing. PDF, probability density function. So probability density function we have already seen here. Fx equal to y is equal to p probability. Probability is calculated given by 1 upon b minus. So 1 upon b minus a for x between a and b, and 0 otherwise. Is this understood? Second row understood? Second row understood?
Yes, sir.
Yes.
When X is between A and B, and you want to find out cumulative probability. See this cumulative probability. See, cumulative probability is nothing but area under this rectangle, right? That area. So if X is in between, so area, and the half of the area of the rectangle will be covered. If X is more than halfway, little bit, so you know how to calculate CDF. So directly you can use this formula for calculating CDF. X minus A, wherever X is always between A and B. Huh? X is less than A, more than A and less than B. Okay. So X minus A upon B minus A. So that is your CDF. CDF is nothing but your cumulative probability. When X is less than A, CDF is 0. Cumulative probability is 0. And when X is in between A and B, it is X minus A upon B minus A. So that is your cumulative probability. What will be the value of CDF for X greater than B? X greater than B. What is the value of CDF? You have agreed here, right? At B, the CDF will become 1, right? Less than A,
Yes,
CDF
sir.
is 0. At B, C will be equal to 1. At B, CDF will be equal to 1 because you have covered complete rectangle, right? So
Yes,
NDI
sir.
under the complete rectangle will be 1. Got it, na?
Yes,
So
sir.
CDF, X less than A will be 0. X between A and B, it will be X minus A upon B minus X minus A upon B minus. And for greater than B, CDF will be 1. Got it? Then mean. How to calculate mean? So mean will be always be equal to A plus B by 2. A plus B by 2. Median will be also, median and mean will be equal A plus B by 2, average. A plus B by 2, A plus B by 2. And mode. So mode in this, mode means frequently occurring value, right? It is occurring most number of times. So it can be any value between A and B. Like 0.2, if it is occurring 4 number of times, and rest all values are occurring only once, so 0.2 will be mode. So it can be any value between A and B. That is your mode. So like I am concerned whether you have understood the formula of CDF or not. First of all, let us revise it once again. For X less than 1, CDF will be equal to cumulative X less than A. The cumulative probability will be 0. Do you agree with that?
Yes, sir.
Yes, sir.
For X greater than B, cumulative probability will be equal to 1. Do you agree with that?
Yes, sir.
And for X between A and B, it is given by this formula, X minus A upon B minus A. So X is any value between A and B. So X minus A divided by B minus. So these are the small formulas. Mean and median are given by A plus B by 2, and mode can be any value between A and B. So any challenge so far in simple formulas? If any challenge, we'll repeat once again, but don't get away with any doubt. Have you understood complete table? This complete table?
Yes, sir.
Yes, sir.
Only one thing.
Yeah.
What is the PDF stand for? That I forgot.
See, PDF means value of probability at that point.
Okay, okay. Got it.
And CDF means less than that, less than equal to that. See, I'm
Okay.
giving you example. Yesterday also, same example I'll repeat. I have collected 50 people from a crowd, like 50 random people I have taken from a crowd, random. Like some random people I have chosen from a crowd or my city market. I went to city market, lot of people are there. I randomly chose 50 people. I asked them to stand aside and then randomly measured their height. And each people I have given number 1 to 50. The first person which I took out, I gave him number 1, and then number 20, number 30, number 50. So like that, each person is numbered 1 to 50. So your value of X is varying from 1 to 50. Okay, right? So how many samples are there in this?
50.
Yes, 50 samples are there, right? What is my lowest value of X?
It's 10.
No.
1,
1, right? And what is my highest value? What is my highest value of x?
50.
50, right? So you understood that.
Yeah, yeah.
Now, I'm blindfolded like you. I'm the guy who is doing the experiment and I'm blindfolded. And then I just go in that 50 people and I just keep my hand on, say, some person. Suppose his number is 29. So number 29, his height is 160 centimeter. So what is this 29? What is this 29 called? See, you told lowest is 1. That means A equal to 1. Highest equal to 50 means B equal to 50. Now I am telling one random person I have taken whose number is 29. What is that 29 is called?
It is X.
That is X. Very nicely understood. So that is X. So a random person I have taken whose this number is 29 and his height is 160 centimeters. Now I am asking you two questions. Listen carefully. Two questions I am asking. What is the probability of me getting a person with height 160 centimeter? Single person I am talking about. What is my probability of getting a person with height 160 centimeter? One question. Question number 1. And my question number 2 is what is the probability of me getting a persons? Now I am talking about multiple persons. What
Yeah,
is
yeah.
the probability of a person with height between 1 centimeter, 160 and 0, 160 and 1. Sorry, 160 and suppose lowest is 130.
Highest
So
value.
no, not here. See, 29% I have taken. Highest our height is 175.
Okay.
Lowest height is 130. So now, what is my probability of getting a person with a height less than equal to 160? Which probability will be more?
Yeah,
First or second?
yeah. Second. It's
Second will be more, right?
Yeah.
So suppose your PDF is first question. PDF is first question means what is my probability of getting a person of a height exactly equal to 160? That is your PDF. At my particular value of x, what is the probability? So my x is 29th person whose height is 160 and that probability of getting a person with height 160 is PDF. I'm asking a second question. What is the probability of me getting a person height less than equal to 160? I'm talking about entire range 160, right? Less than equal to 160. So that is called CDF. Understood?
Yes, sir. Clear now.
Okay, so difference between PDF and CDF understood? Anybody?
Clear, sir.
Understood, na?
Hmm.
So area under that curve, so that will be 1. Maximum value of CDF will be equal to 1. Minimum will be 0. Like probability also, minimum 0, maximum 1. Okay. So CDF is a ever increasing function. Like is it decreasing between A and B? Like a cumulative CDF function, is it decreasing between A and B? More and more area you are covering as you are moving from A to B, right? Is it decreasing between A and B? First of all, my question is
No, sir.
not decreasing. Right? So CDF for any distribution, whether it is normal, T, or uniform, whatever distribution you take, cumulative distribution function is always a ever increasing function because it will increase from 0 to 1. Understood why? Because it is given, it is area of the area under the curve, right? So see, it's area under the curve. I will take you again to that curve. I'll take you again to that curve. That what we have taken like this curve. Now I start with minus 7 and go on increasing towards right. So that's what is my CDF. I start with minus 3 and go on increasing towards 3. So that area which I am covering of this curve, is it increasing or not?
Yes, sir.
It will go on increasing till 3, right? At minus 3, the area which I am covering is 0, and at 3, I will cover the complete curve, right? So area will be 1. So CDF is always a ever increasing function. Got it? So
Yes,
that's how
sir.
it is. So that's we have covered, and this distribution like your uniform distribution, there is no parameter, only lower value and upper value. Formulas are given by this. Okay.